Hey guys, for this video, I'll be sharing with you what a Wallaby task looks like and what will be the workflow for Wallaby. So right after we open a task, as you can see, Wallaby tasks are now set up to LiDAR light. And right after you open a task as well, we'll be checking the camera just so we will know the potential missing areas that we are trying to annotate. So right after we analyze the scenario, we now then proceed to our annotation. So we will be annotating this vehicle as an example. So in this workflow, first step is we try to annotate vehicle. The sizing will be getting all the points available. So we don't should not forget putting a label and marking the vehicle as dynamic. So now on this part, we'll make sure that we are able to get the first frame of the vehicle. So this is the first frame. We're at 0.1s, and this will be our last frame at 6.6s. So as you can see here in the first step, when you turn on the dynamic APC, sizing is not correct yet. Pathway is not that smooth either, and sizing is not perfectly correct. Positioning is not yet correct as well. As you can see, when you try to scrub the scenario, there are internal slipping points for the vehicle. So there are also echo points and reflection. Once you are able to complete or get the first and the last frame, we now then proceed to our next step, which is calculate activation. Calculate activation does remove all the echo, noise, and shifting on the dynamics. So this will be our second step. So right after you click the dynamic APC, calculate activation, you'll directly see the difference between the two objects. Once you remove again the activation, there are multiple echo and noise and double points on the vehicle. So it removes all the echo noise. So that will be the second step. And once you successfully calculate activation, we will now then proceed to our third step, where we fix all the positioning, the sizing, pathway for this vehicle. So we will start fixing the keyframe that we already added. So then we will try here to fix the sizing. So we have here a dense points for this vehicle. So for its sizing, we'll just be basing it on the vehicle points. So while we are also fixing the keyframe, we want to make sure that we are also including the pitch and roll on our fixes. So the actual sizing for this vehicle will be 4.3. So I can adjust it more. if in case there are necessary adjustment for its pitch and roll, we want to make sure that we are able to properly position the pitch and roll for this cuboid. So right now we're just scrubbing all the scenario. There. So as you go through all the frames, it's very important that we are able to cross-check as well the dynamic APC if we are able to fully annotate the vehicle properly or fully position the vehicle properly. So there is a antenna for this vehicle, so we include antenna as part of the vehicle. So we adjust the cuboid sizing up until this point right here where it looks like a antenna for the vehicle. So once you are able to position the vehicle correctly, we will now then proceed on its attributes. So the vehicle is not towing any object, so it will be marked as no. The vehicle as well is not carrying or pushing any object, so it should be marked as no as well. For its turn signal attribute, since the vehicle is not on the SDC lane, we should not be marking it. So we should leave it as is since it's not on the vehicle, it's not on the SDC lane. So that would be the basic workflow that we'll be doing on Wallaby. So the difference is just on the other project we don't have any calculate activation. Here in Wallaby, due to calculate activation, there will be 3 steps on our workflow, and then our keyframe are converted to seconds. So that would be changes on Wallaby task. Other instruction and information will be discussed later on this course.